All right, let's dive right into this explainer and build some serious coding confidence. Today, we are completely demystifying a core concept, exactly how Java compilers differentiate method signatures. If you've ever felt, just totally overwhelmed by random compiler errors or super clunky naming conventions, you are absolutely in the right place. We're going to break this whole thing down so you can write cleaner, way more intuitive code without ever second-guessing yourself.
To really get this, picture this scenario. You're moving to a new apartment, right? You walk into your local bank branch to update your profile, and you cheerfully tell the teller you just need to update your address. They hand you Form 101-A. Simple enough. But then, you casually mention you're also going to scribble your new phone number at the bottom. Suddenly, the teller just gasps, clutches his chest, and drops his coffee mug. He screams for security, yelling that Form 101-A accepts exactly one address string, and if you add a phone number, the universe is literally going to implode. He demands you shred the form, go stand in a 2-hour line, and request a totally different document, Form 102B, just because you added a phone number.
Section 1. The Procedural Coding Nightmare. Life before overloading.
Now, that absurd, overly dramatic bank scenario, it actually hits the nail on the head when we look at the rigidity of procedural C programming. You just can't use one flexible form for multiple related tasks. In C, the standard library literally forces you to memorize these absurdly distinct function names for the exact same conceptual operation. Like, if you want the absolute value of a standard integer, you use absx. But if it's a long integer, well, you've got to remember to use labsx. A double? That's fabx. The cognitive load is just unnecessarily huge. Compare that to Java's unified clean approach. You really shouldn't have to change the name of the action just because your data type changed.
So here's the deal. The C compiler identifies functions strictly by their identifier name alone. If you write two functions named updateDetails, where one takes just an address and the other takes an address plus a phone number, the C compiler just crashes with a redefinition error. Even though the parameters are completely different, it simply cannot handle two functions sharing the same name. Period. We obviously need a better way to do this.
Section 2. The Java Solution. Enter method overloading.
Luckily, Java steps in and totally fixes this procedural nightmare. Think of Java's method overloading as a flexible, modern bank form that actually lets you reuse the exact same method name, like updateDetails, for different variations of a task. But to wield this superpower, we do have to play by the compiler's rules. We have to understand the secret sauce, the method signature. This is what makes each version of your method totally unique to the Java compiler. A signature is defined strictly by just two things, the method's name and its parameter list. And when we say parameter list, we specifically mean the number of parameters, their exact data types, and the sequence they're written in.
Section 3. Decoding the golden rules. Outsmarting the compiler.
So how exactly does the compiler decode these signatures at the call site? Understanding this is where your coding confidence is really going to skyrocket. Here is your ultimate rulebook. To successfully overload a method in Java, meaning using the same method name multiple times in the same class, you absolutely must alter at least one of these three things in your parameter list: the number of parameters, the types of those parameters, or the order of the parameter types. Let's actually look at how each of these plays out in practice. First up, overloading by parameter type alone. Say we call updateDetails and pass in mgroad, which is a string. Then, in another spot, we pass in 56,001, an integer. This works flawlessly. You don't even need a different number of parameters. Just changing that data type creates a totally distinct signature. Java looks at the argument, spots the string versus the integer, and instantly routes them to their correct, distinct versions.
And you know what? Overloading by the order of parameters works just as perfectly. A method accepting a string followed by a long integer is treated as a completely different blueprint than a long integer followed by a string. Because that sequence changed, Java knows exactly which one to execute based purely on the order of the arguments you hand it.
But watch out, because here is the classic trap. This is where a lot of developers literally lose their coding confidence. Critical rule: return types absolutely do not count. If you have two updateDetails methods that both take a single string parameter, but one returns void and the other returns a Boolean, if you try to compile that, bam, instant compiler error. Changing only the return type, or just swapping the variable names inside the parentheses, does not create a new signature.
Now, you might be wondering, why on earth does this fail? Well, put yourself in the compiler's shoes for a second. If you change the return type, but keep the parameters completely identical, how could the compiler possibly guess which version you mean when you actually invoke the method?
Think about this specific line of code. Customer.updateDetails mg_road. Notice what's missing? The programmer isn't even capturing a return value. They aren't assigning a result to a Boolean variable or anything, and that's perfectly legal in Java. But if we had those two methods from earlier, the void one and the Boolean one, and the programmer writes this ambiguous call, the compiler is totally blind. It has zero clues whether you wanted the void version or the Boolean version. This is exactly why Java completely ignores return types when determining overload uniqueness. It has to rely purely on the inputs.
Section 4. Test your coding confidence. From theory to real-world practice.
Okay, let's transition from passive listening to some active engagement here. It's time to put on your compiler hat, look at these next combinations, and tell me which one is going to make the Java compiler completely riot with a compile time error.
We've got combination A, which has two process methods. The first takes an int, then a double, and the second swaps them, taking a double, then an int. Then we have combination B, two calculate methods that both take two integers, but one returns an int and the other returns a double. If you guess combination B is the troublemaker, you nailed it. Combination A perfectly follows our rule of changing the parameter order, but combination B tries to cheat by changing only the return type. And as we just established, that violates our critical golden rule.
Let's tackle one more. This is a real-world design challenge. Imagine you're tasked with building a single, unified notification service for your entire company. You need to send 3 entirely different types of messages: in-app alerts, SMS texts, and emails. How would you design this using overloaded methods so that your fellow developers just have to call one simple, memorable method name?
The solution here is just so elegant. By leveraging method overloading, we use the exact same send method for all 3 actions. Step 1. For the in-app alert, we just pass a single parameter, send string message. Step 2. For SMS, we switch up the number and types, send long phone number string message. Step 3. For email, we expand it again, send string email, string subject, string message. We've solved the whole thing without forcing our team to memorize messy names like send app alert or send email. It's just incredibly clean code.
So we've completely escaped those rigid, panic-inducing forms of procedural programming and unlocked the flexible, unified power of Java method overloading. You now know exactly how the compiler reads your method signatures and, crucially, why it totally ignores return types. So with this rulebook officially mastered, I want to leave you with a thought. How are you going to use this superpower to clean up your own codebase, ditch those redundant method names, and tackle your next big project with absolute coding confidence? Keep that in mind the next time you're architecting a class. Thanks for joining me for this explainer, and happy coding.